In 1906, British geologist Richard Oldham was analyzing seismograph readings caused by a large earthquake when he saw something odd. As the vibrations from the quake reverberated, they did not arrive at the center of the Earth as expected. It was as if they'd hit an obstacle. Oldham realized the obstacle must be the innermost part of the Earth, a dense mass hard enough to have deflected the seismic waves from going all the way through. Oldham had discovered the Earth's core. It was a landmark discovery because it set the stage for the work of another scientist who was about to help revolutionize our understanding of what was happening inside the Earth. With Oldham's discovery, many believed the picture of the Earth's core was complete. But in the early 1930s, Inge Lehmann wasn't so sure. Lehmann was a Danish seismologist who worked extensively in Denmark and Greenland, studying the velocity of seismic waves from earthquakes. In 1936, she was analyzing the seismic waves from an earthquake that had occurred several years earlier. Seismological stations around the world had made recordings of the same quake. By comparing their readings, Lehmann calculated that as the seismic waves had passed through the Earth's core, there was a change in their velocity, as if they had encountered another boundary of some kind. Then it occurred to her. Something was missing from the accepted structure of the Earth's interior. The Earth didn't just have one core, it had two. The core that Lehmann had found was the Earth's inner core. Today, through precise seismic measurements, we know that it's made of solid iron. Solid because gravity at the center of the Earth creates a pressure 3 million times the pressure it exerts on the surface. The core that Richard Oldham had discovered turned out to be the Earth's outer core. It's made of liquid iron and other elements, a hot churning mass that generates electric currents, which in turn create the magnetic field that protects the Earth from dangerous cosmic radiation. Together, the two cores that Oldham and Lehmann discovered form a massive structure over 4,000 miles in diameter, slightly larger than the planet Mars. At the center of the core, the temperature can be as high as 13,000 degrees Fahrenheit, which is 2,000 degrees hotter than the surface of the sun.